Welcome to Nole, the official podcast of the College of Arts and Sciences at Florida State University. I'm your host, Amy Walden, and today we welcome Paul Cottle, the chair of the Department of Physics and a member of the FSU faculty since 1986. Paul, thank you so much for joining us on the podcast.
Thank you so much for having me, Amy.
Absolutely. So on today's episode, we're discussing all things physics, from happenings in the department to pathways for students that ultimately lead to successful careers in physics and other STEM fields. Paul, before we jump in, let's take it back to before you even started teaching at FSU. Can you tell us how and when you first became interested in studying physics?
Well, people are so used to physicists saying, oh, I knew when I was 6 years old I wanted to be a physicist. And my story is kind of the opposite of that. I sort of picked a school. I grew up in Connecticut, and I picked an engineering school in Massachusetts that had an unusual curriculum that appealed to me. But the summer before I went there, they wrote, you get the form and it says, what do you want to major in? I'm like, well, I hadn't thought about that, So I just wrote down physics because I didn't know much about physics. I'd enjoyed my high school physics class. And I figured it was generic and I would change my mind later. But when I got there, I never changed my mind. My professors kept saying, hey, you're pretty good at this. Just keep going. And I just said, okay, I'll do whatever I'm told. And went off to graduate school and then to Florida State University. And I'm still here 39 years later.
The rest is history.
Yes, it is.
So what are your areas of physics research here at FSU?
I am a nuclear physicist and experimentalist. I do a lot of experiments here at the John D. Fox Accelerator Laboratory that you featured in Spectrum this winter. In addition, I do experiments at the Facility for Rare Isotope Beams at Michigan State University. That is a major national laboratory. The director of the laboratory is a fellow named Thomas Glassmacher. He was my first PhD graduate back in 1992.
No way. How cool. Yeah. That's awesome. So what do you think sets FSU's physics department apart from other programs around the state or the country?
Well, first of all, this has to be said that we are an outstanding research department. I told my faculty just a few weeks ago, I said, this is an incredible intellectual resource for the state of Florida, and I'm honored to be the steward of that resource as chair. But maybe more importantly, and if there's any parents out there wondering, well, maybe I don't want my kid to be in the middle of an intellectual resource, it is a group of 50 professors who value students very, very much and care a lot about their futures. It's a department that is a great team. We're great teammates. People work together very well. And our students at both the undergraduate and graduate levels benefit from that. I think that's what sets us apart. My colleague Susan Blessing said once about another university in comparing us to another university in our state, which I won't mention. They tell you how great they are. We tell you how great you can be.
I love that.
So, we're all about our students.
Yeah, it definitely makes a difference. And I think just seeing some of the members of the department, you can tell right away that that's a big difference. So the department launched its Studio Physics program in 2008, aimed at improving student success. Can you tell us a little bit more about this program?
Well, physics education researchers had been looking for ways to help students learn physics with more understanding for decades. And some researchers at North Carolina State University came up with a scheme. The basis of it is, we all know as human beings, we do hard things best together, right? We want to work together to do hard things. I mean, look at athletic teams, right? They accomplish things together that they could never accomplish on their own. So what we wanted to do, what the North Carolina State people wanted to do, and ultimately what we wanted to do, was foster those relationships among students, and then foster relationships between the students and the instructors in the classroom. And that was the basis of the Studio Physics program that we started in 2008, a long time ago. And that program has gone through several changes and some evolution. But I can tell you that as of 2026, every STEM major at FSU who takes a physics course, and that's like almost all of them, have some of their classroom time in sessions where elements of the Studio Physics program have been implemented. This is every student. We started as a small experimental thing, and ultimately we're everywhere. Every student gets the benefit from this work.
Yeah, we actually talked about that a little bit in Spectrum magazine as well, and it was really cool to sit in on one of those classes and see how the students work together.
Yes.
It was really a unique experience. So, as a longtime member of the department, you've seen thousands of students complete their college journey here. What are some of the different career paths that you've seen graduates of the physics department go into after their time at FSU? And in what ways have these career fields changed over the years?
Well, that's a really interesting question because most parents and students think of, oh, if I'm going to major in physics, I have to go into academic research. It's the only career path. And it's not even close. About half of the students who earn bachelor's degrees in physics here and nationally end up going into the workforce right away, right after graduation. They're doing things like engineering, information technology, all kinds of things like that. Some of them end up teaching high school physics, of course, which is a very important career path. And then, some go off to graduate school in physics or in astronomy, but not all of them go to graduate schools in those fields. About 8% of physics bachelor's degree grads go into engineering graduate school. Some go to law school. My son went to law school after earning a degree in physics. Some go to medical school, and they do very, very well because, of course, they're strong students. They earned a bachelor's degree in physics. One of the things to keep in mind here is that some very famous people that you know about were undergraduate physics majors or wish they were. Elon Musk was a double major in physics and economics at the University of Pennsylvania. And the CEO of NVIDIA recently said, now he earned his bachelor's degree in engineering. He said, I wish I'd been in physics. And he suggested that students who are thinking about careers in the new technological economy major in physics. Physics majors, even at the bachelor's level, are the utility players of the modern economy. And I saw a statistic a few months ago that kind of caught me off guard. The average salary of FSU physics bachelor's degree graduates is $105,000 a year. Okay? That includes the teachers who are making a lot less than that. It means they're balanced off by people who are making a lot more than that. So, yeah, this to be a surprise to parents, to students. Physics is a great workforce degree.
Okay, I'm sold. I'm going into physics now. So the department hosts several community outreach events throughout the year, including things like Saturday Morning Physics and the Flying Circus of Physics, which is a lot of fun. Can you tell us more about some of these outreach events?
Well, we have the Physics Open House that attracts about 1,000 people from the community every second year. I think this is an off year for us. We'll try it again next fall. The Saturday Morning Physics program has been running since even before I got here in 1986, and I can't tell you exactly what year it started. But for years, that brought in a lot of high school students. But the Saturday Morning Physics Committee has been changing direction to focus more on middle school students. And that change is really significant. When we talk about preparing K-12 students for careers, not just in physics, but in other math-intensive STEM areas like engineering and computer science, that preparation has to start in middle school. And this is what we're focusing a lot of our new research effort, our new outreach efforts on. For example, on February 24th, I'll be at FSU PC, the Panama City campus, for an event called Future Physicists of Florida, in which we honor and recognize, it'll be between 100 and 150 middle school students for their talent and interest in math and science careers. And I can tell you, this is usually the first time the kids have been honored for anything, and their parents are just crazy happy.
I bet.
And there's more cameras, the parents coming down the aisle taking pictures. So that'll be great. It'll be great to be back at FSU PC doing that. We've been doing that for about a decade. The other event out near Panama City is the Nuclear Medicine and Science Camp. And I've got my prop here, so I'll pull this out.
Yes.
Put it right here. Make sure it's on camera.
Love it.
Yeah, so every summer since 2018, we've hosted about 20 middle school students in a camp that's extremely hands-on. The equipment we use costs about $50,000 to run the camp. Fortunately, we have a grant sponsor, the National Nuclear Security Administration, which funds us through a consortium called Centaur that is headquartered at Texas A&M University. FSU is a major partner of that consortium. Our Camp has been so successful that it's spun off new camp sites in several locations in Texas. There's a new camp starting in Baton Rouge, Louisiana shortly. But once again, the focus on middle school kids. You know, there are kids like girls and minority students who tend to kind of spin off away from math-intensive STEM careers. If you catch them in middle school, I mean, we don't have to do any kind of fancy doing anything. We just say, come sign up for our camp. And we get a nice mixed camp. And it gives the girls an opportunity to find out what it's like to be, scientists before they start thinking about other things and maybe drift off because it doesn't seem so interesting. These have been very successful that way. And we're really eager to keep doing this stuff. This year's Nuclear Medicine and Science Camp will be at Mosley High School in Lynn Haven, north of Panama City, in the month of June.
Awesome. Yeah, I remember seeing photos from the camp last year, and all the students just looked like they were having the time of their lives with those experiments. So we touched on this a little bit already, but I'd love to hear more. Why is starting physics education at a young age, well before a student gets to college, so important?
We want students, not just physics majors, but the other students who take our introductory physics courses, students majoring in engineering, students majoring in meteorology, computer science, mathematics, biology, biochemistry, all these fields. We want them to be successful when they come take their physics classes. And we want them to be successful in their other subjects as well, especially in their foundational math and science courses, kind of are the gateways to their advanced studies that they'll do as majors in those fields. So we want them to have the correct background in high school, the high school courses that will give them the best possible opportunity to succeed when they get here. What are those courses? It's really not a long list. We have so many students in the state of Florida. About a third of the students in the state of Florida take Algebra 1 in middle school. They are on track to take a calculus course when they're a senior or even a junior in high school. Nevertheless, only 10% of those middle school Algebra 1 students ultimately end up taking a calculus course. We want to encourage more of those middle school Algebra 1 students, and of course their parents, because this is all about the parents, to persevere until those kids take a calculus course in high school. That will open doors for them. That'll make it easier for them to graduate in 4 years, even if they have a taxing major like engineering or physics. In addition, it makes sense that if you're going to take a college physics class, if you've taken a high school physics class, you're going to have a head start when you get to your college physics class. About a third of the students at Florida State Universities in my college physics classes had not had a high school physics class. That, on the average, cost them a full letter grade. Wow. And that can be the difference between getting a B and a C, keeping your Bright Future Scholarship and not keeping your Bright Future Scholarship. And when it comes to students who want to go to medical school, think about this. Every grade they earn in college, in their undergraduate years, is going to go directly onto their medical school application. Let's see. If I take a high school class, maybe I get an A in college physics. If I don't take a high school physics class, maybe I get a B. Who cares? Well, it's on your medical school application. It matters a lot. So we want students to get that calculus course in high school if they can. We want them to take a high school physics class. We want them to take a high school chemistry class for exactly the same reasons, because all of these students have to take college chemistry. We want them to succeed when they get here. The worst part of being a professor in those classes over the years was seeing students who I knew could have been successful, but weren't, because they weren't prepared properly when they arrived on campus here. That's heartbreaking. That's heartbreaking, of course, more for the student and more for the parents than for me, but it was also heartbreaking for me.
Yeah, that's great advice. And I think, there's a lot of stigma around certain, high school classes being difficult, but if it's going to save you a lot of trouble down the road, that's the main thing.
Take up your challenge in high school. It really is important to take advantage of the opportunities you have in high school. I tell students, you're better off taking your first calculus class from a high school math teacher who's used to working with 17-year-olds than you are waiting until you get here.
That's a great point. So you're very active in the conversation surrounding physics education, and you even have a blog called Bridge to Tomorrow, which you started back in 2009. Can you tell us what inspired you to begin this project and some of what it touches on?
Well, I was a member of the committee that wrote Florida's new K-12 science standards in 2007 and 2008. So I was immersed in all of these education policy issues. And of course, I'm a physicist. I think I have all these ideas, right? So I wanted to write them all down, but there wasn't enough room on the state's op-ed pages to write them all down. So finally, a couple of reporters from the St. Pete Times, which is now the Tampa Bay Times, said, "You really ought to start a blog, Paul." I think they said it for my mental health. But yeah, that was 2009. And I've been posting ever since. I've got to admit, I'm posting less since I'm department chair in August, but I posted yesterday morning about a policy issue. So it's been a great opportunity. And some wonderful people read these things. There's some real surprises. I'll get an email from a reporter who says, "I saw you said this." I said, "You did see that I saw?" I mean, yeah, you always assume nobody's going to read it, but then it turns out sometimes
Yeah,
they do.
absolutely. The word has gotten out for sure. What do you think is the biggest misconception surrounding physics education or physics careers?
Well, just to come back to what I was saying before, physics is a workforce degree. Nobody thinks of it that way, but it is a great workforce degree. You have to learn how to program computers while you're a physics major. You have to learn a lot of mathematics. You have to learn how to look at a data set and make sense of it. Not just, crunch it, but to look at it and say, "Oh, I see what this data is trying to tell me." I mean, these are the skills you learn as a physics student, both at the undergraduate and graduate levels. Those skills are really important. They set you apart in the workforce. I mentioned my son who went to law school. I mean, he's a dynamo when it comes to quantitative issues coming up in his litigation practice. I mean, people don't think of that. But if you can handle quantitative issues as physics students are trained to do, it opens doors in an enormous range of fields. Like I said before, physics students are the utility players of the technological economy. They can do anything. I actually got the dean of the College of Engineering to say that recently. They're talking about starting a new nuclear engineering program, and they're saying, where are our students going to come from? And it turns out one of the hardest things for new nuclear engineering graduate students to do is learn quantum mechanics, which of course every physics major does. They love physics majors. "Oh, I love physics majors in nuclear engineering graduate programs," said the dean. So we're going to feed him some. We're starting a new major track that's going to interact with what the College of Engineering is doing, and we're going to make them very happy.
Wonderful. Well,
Yeah.
I can't wait to hear more about that. That's exciting. So what would your advice be for a student who is maybe interested in getting started in the realm of physics?
Well, first of all, find TV shows, find podcasts, find everything you can find out about how the universe works. Just to give you one example, most people have heard of the Big Bang, right? We assume, boom, the universe went up and it was going to get bigger and bigger and then come back down and eventually have a big crunch. Because, if you throw a ball in the air, the ball slows down and it comes back down. I mean, so the universe was going to get pulled together again by gravity. 30 years ago, everything changed. There was an observation that even the experimentalists who made the observations didn't believe at first until there were two competing groups. And one group said, "This can't possibly be right." The other group said, "This can't possibly be right." And then they talked to each other and they realized they were both getting the same wrong answer. It was the right answer. And that was that the expansion of the universe is not slowing down. It's actually speeding up. And so there must be something called dark energy. 70% of all the energy in the universe has to be dark energy. And there's all kinds of literature out there, popular level stuff. So learning about these things is really important. Learning about the new revolution in nuclear power. All these things, read about them. But then, on top of that, you have to do the work. And that means taking algebra in middle school, sticking with it until you take calculus in high school. Make sure you everybody in the state of Florida has to take a biology class. Take that chemistry class. Take the physics class. If your friends aren't taking them, do it anyway, because that keeps the door open. It gives you options when you get to college.
Great advice. So, if anything that Paul said today was interesting to you, maybe check out physics. All right. Well, Paul, we end every podcast with our bowl of mystery questions.
Okay.
So, please draw one and answer.
What was your first pet? So, we had a miniature schnauzer named Bonnie. She was wonderful. She had a son called Matthew, who we kept for a while. But I've got to tell you, we don't have pets now. We let our kids have the pets. We have 2 grandchildren and lots of dogs. So we always have reasons to go visit and borrow our children's pets.
I love it.
Along with their grandchildren.
That's perfect. Well, Paul, thank you so much for joining us today on the podcast. And if you would like to learn more about Paul Cottle and the program offerings in FSU's Department of Physics, visit physics.fsu.edu. Thanks for tuning into Nole Edge, and we'll catch you next time.